All right, welcome. I'm very happy to be here today, also that you came so many to this introductory talk about Kubernetes Probes. So my name is Claire. I'm working as a backend developer and also additionally as an engineering manager at a company called JobLift. We are working in the recruiting space. And today I want to give a bit an explanation what Kubernetes Probes are, why they are there, why you should use them, why you should maybe not use them. Before we get started, I want to make a little assessment of the audience, so to understand a bit on which level I can do the talk. So, who of you has never heard of Kubernetes? Don't be shy. All right, no hands going up, that's a good sign. Who has never worked in a live productive environment with Kubernetes? Okay, quite some hands going up. So I hope I'm at least telling you something new today. And of those who have worked on the productive environments, did you ever care about probes, or do you have DevOps engineers or someone taking part of it? So who's taking care of their probes themselves? Well, at least some people. So I hope I'm not boring you too much. Yeah, to be all a bit on the same level of understanding, let's start just to summarize again, what is actually Kubernetes? So Kubernetes, you will see in documentation, you will very often see the abbreviation K8S, is a container orchestration engine. So what does that mean? You have a cluster, you have different nodes, and you have application containers that you want to run on them. Then Kubernetes is actually an abstraction layer that takes care of certain tasks for you. It takes care of deploying the stuff, of scaling, of making sure that containers are running, that they are scheduled, that enough instances are running, and so on. So Kubernetes was originally developed by Google, so they used it internally for their large cluster environment, and it then got released in 2014, so already quite some years ago, and is in the meantime part of the Cloud Native Foundation. Kubernetes is written in Go, in case you ever want to write some code for it. So also, let's look a bit at the components that Kubernetes has and that are relevant when we want to understand what probes are and what we use them for and how they can help us. So first of all, we have the nodes. So you have a cluster with 1 node, 2 nodes, 500 nodes. It's basically either a physical machine or a virtual machine in your cluster. And on those clusters, you have pods. In Kubernetes, pod is actually the smallest deployable unit. So a pod has its own IP address, and a pod can be one container, but a pod can also be 2 containers if you want to group 2 containers together because you have one main application, for example, and you have a sidecar container for the database connectivity, for example. So that's a pod. Then we have a deployment. What is a deployment? A deployment describes what your application state should look like. So how many instances of my application should I have running? What are the resources? How much CPU should it get? How much memory should it get? And it also describes those probes, those Kubernetes probes we want to talk a bit about today. And finally, we have one more thing, which is the service. Basically, you don't need to have a service, but the service allows you to enable to route network to your different instances. So basically, let's think of microservices. You have a microservice architecture. You have one microservice. You would describe in a deployment what that microservice looks like. You would say, okay, that microservice, it needs 500 megabytes of memory, and I want to give it 1 share of CPU. But then you want to route traffic to those microservices, and you said also, well, I want to have 10 instances of my microservice running. So you have the service, and the service kind of keeps track of the different IPs of the active pods, and then it routes the traffic to them. So this is very high level, but just to kind of so we all have the same understanding of what we are talking about. Then there's one more thing that is super important for Kubernetes and also for the probes, which is the kubelet. So on each node in your Kubernetes cluster, you have this kubelet running. It's the primary agent that you have running on each node. So it's basically a process that kind of takes care of managing all the pods that run on its node. Right? It's not responsible for the pods on the neighbor node. It's really just responsible for the pods on its node, and it's also not responsible for everything that's not managed by Kubernetes. So it really takes just care of the stuff that's managed by Kubernetes, and it regularly triggers those probes. So depending on the interval you configured, it kind of asks the service, hey, are you still alive? Are you ready to accept traffic? Have you been started? And it also takes care of making sure that if you said, I want to have 5 instances, aligning with the API server, that you have those instances. But the main task in our use case is that it periodically triggers those probes. So now, what are probes actually? So probes are a mean of the kubelet to regularly perform checks on your container. We have 3 different kinds of probes in Kubernetes. We have readiness probes, we have liveness probes, and since version 1.20, which was released in December 2020, so about 2 years ago, we also have startup probes. And for each probe, you have 3 possible outcomes. So either the probe is a success, then all is good, or it's a failure, which isn't good, and then certain actions are taken, depending on which of the 3 probes we are in, or it is unknown. So unknown is usually a status that shouldn't happen, and it usually means there's some kind of communication issue on your node, and then the kubelet takes further actions. But we mostly want to focus on the success or on the failure status. And then in your application, you actually have the possibility to support 4 different types of 4 different mechanisms to trigger those probes. So I think the most common one is probably the HTTP GET, which is a normal GET request that's executed by or triggered by the kubelet towards your application, and then your application response. So response codes between 200 and less than 400 are considered as a success. Everything else is considered as a failure. Then we have TCP sockets. So basically there you specify a TCP port, and the probe is successful if that port is open. So if the kubelet can reach the port and the port is open, the probe is marked as successful. Then there is gRCP probes. This is also relatively new. I think it's actually still in the beta status. So there, the kubelet is basically triggering a remote procedure call on your application, and the application should implement the gRCP health checks. And finally, there's the exec or the command. So this one, it executes a certain command on your container. So for example, I don't know, you could grab for a certain process to be running if you use the exec command. So now let's look a bit deeper at what the 3 different types of probes are, starting with the liveness probes. So the aim of the liveness probes is actually to answer the question, is my container running? So if yes, everything is good, and if no, the container is killed. So and then the restart policy is applied. The liveness probe, if you don't provide one, it just per default is success. An example use case for liveness probes are, for example, deadlock detection, and that shows you already. Well, your application shouldn't have deadlock detection, deadlocks at all, right? And if it has them, it should ideally kill itself, I don't know, using a system exit or something. But it can happen that, I don't know, in the middle of the night, there's a deadlock, you are able to detect it, and then maybe it's better to actually restart the container and then get out of that situation. But the liveness probe is also somewhat dangerous, because imagine in your liveness probe you define, I don't know, if the database, I cannot connect to the database, my pod is not live. Which might, in the first step, this might actually sound reasonable, right? I cannot connect to the database. Well, why should my application be live? The problem now is if you have 10 instances of your service running, because well, you have a lot of load, right? and then the database isn't available, all 10 instances of those service will get killed, and then they will start again, and then the liveness probe will fail again. So they come into this what we call the crash loop, right? They get constantly restarted. And now imagine you just need the database on startup to load some stuff into memory, and then you cache it, and your container would actually work perfectly fine, even if the database is unavailable for 10 minutes, right? So it is actually useful to be a bit careful of when to use the liveness probe. The liveness probe is triggered on a defined period all across the life cycle of the container. So from the start to the end, the liveness probe is continually triggered. Then the second probe we have also available since the very first version of Kubernetes is the readiness probe. And readiness probe, contrary to the liveness probe, it doesn't check if the container is up and running, but it tells us whether the container is ready to accept traffic. So imagine you have an application that starts a web server, and then it accepts requests from the outside. But the start of that web server might take some time. So you want to say, okay, I'm not ready. I'm started. I'm already doing some processes, so I'm live. But I'm not actually yet ready to accept traffic from the outside. Another example is cache reloading, for example, or batch processing. So imagine you have 10 instances once again running, and at 3 o'clock in the morning, you want to trigger that invoice run, but you just want to trigger it on one container. The other 9, they can just continue working as normal. So what you could do is you could say on that container, I let it do its batch processing. I remove it from the service, so it will not get any additional traffic, but it is still live, right? There's no need to kill it. On the contrary, it might actually be good not to kill it. But I don't want it to get additional traffic. So I would have 9 containers that are ready. I would have that one container that does its batch processing. It takes 10 minutes, and then it says, OK, now I'm ready again to accept traffic. And then the kubelets at its IP is again knowledgeable to the service, and traffic can be routed to it. So 2 important things to know is also the readiness probe is running throughout the container. So you need to be careful if it's, I don't know, you say it should run every 2 seconds, and it's doing something that causes to cause load on the container. Well, every 2 seconds you're executing that. And the liveness probe does not wait for the readiness probe to be ready. And then finally, 2 years ago, the starter probe was released, and it actually answers to the question, is my application container started? So if the answer is yes, all is good. If the answer is no, the container is killed, and also here the restart policy is applied. If I don't provide one, the default is it just defaults to success straight away. The difference here between the liveness and the starter probe is that the starter probe actually it's just executed once at the very beginning of the container. Sorry about that, and it just disables the other 2 probes. So neither the liveness nor the readiness probes are executed until the starter probe is ready. So for example, if you say, when my container starts, I need to load some data in memory, and it's not ready and not live until that is done, you can configure a starter probe, and then once that is done, it says, OK, now I'm started, and then you can start triggering the liveness and the readiness probe. So there's no need to trigger those liveness and readiness probes if you know, well, it takes some time on startup. So that's what the starter probe is about. So now let's look at how we can configure those probes. So the probes are configured on the deployment file. I will also show a little example later what that looks like. And we have a couple of different configuration that we can use for that. So first of all, there's the initial delay in seconds. So it is the delay until the probe is started the first time. It defaults to 0, so they would start straight away querying the container whether it's ready or not. Then there's the period seconds, which defines how often the kubelet is executing the probe on the container. It defaults to 10, so basically every 10 seconds it would ask, hey, are you still live? Are you still ready? There's the failure threshold. So that one says, how often does the probe need to fail until the container is actually considered, the probe is actually considered to fail? Like for the readiness probe, that would mean how long does it actually take until the container is not ready anymore. So that means if you define a readiness probe, you say it should be triggered every 10 seconds, and it should have a failure threshold of 3. It actually takes you 3 times 10 seconds to see that the container is actually really not ready anymore and remove its IP address from the service routing, which could cause other containers still calling it, even so it is not ready. So you kind of need to select your periods in second and your failure threshold successfully. And then there's the success threshold, which is a bit the contrary of the failure threshold, where basically we say, okay, how many successes does it take until my probe becomes successful again? So it was failed because we said it's not ready anymore. And then how often do I need to query my container with a positive response until I say, okay, now it's ready again, and I can put it back into the IP tables. And finally, there's the timeout in seconds that defines how long should it take for the probe to time out, and this one just defaults to 1 second. So this is actually an example from a Java service, a Spring Boot Java service, where we defined a liveness probe and the readiness probe. So it's a plain HTTP GET on the liveness and readiness probes that are basically available out of the box on port 8081. And yeah, for the liveness probe, for example, we configured here. I don't know, can you see that? The initial delays of seconds, we said, okay, it should only start triggering after 60 seconds and a timeout of 3 seconds. And yeah, we didn't define a period, so it will just trigger every 10 seconds. It will use the default. And for the readiness probe, pretty similar, different endpoint that's called here, and including the period of seconds to 5 seconds here. All right, just to summarize a bit, or what are some hints or best practices when using probes. So when you have containers or services that are accepting requests from other services, it is useful to always define that readiness probe, because of the example I also gave before, right? I have microservice A that's calling microservice B, and then I have 5 instances of microservice B, but one instance is no longer ready because it's having this batch process and all its resources are used up, and it doesn't have any place to respond to that incoming request. So if I have the readiness probe, I can actually say, hey, don't route any traffic to me, and then my microservice B, it will still get a response. However, if I don't do that, it might get routed to that one service that's kind of busy or occupied, and then it will get either a connection refused or connection reset exception. So there are different use cases there. On the liveness probes, you should be a bit careful on them, because you can have those cascading restarts down the line. So all of a sudden, all your containers are restarting, and none of them is available anymore. So you should always see, okay, I have the known bugs, kind of, or the known reasons of why my container should restart itself. You just kill it with the system exit, and the liveness probe should more be the exceptional case. And if you are checking on external dependencies, it's good to adjust the timeouts accordingly, because let's say for some reason on startup you want to make sure that the database is responding. You do a query on the database, but the database takes 2 seconds to respond, a bit long, but you never know. And you set your timeout to 1 second. Well, you will get into trouble. And also, some recommendation is to regularly revisit those things. I mean, in general, it's a good recommendation to also on the deployment revisit CPU settings and memory settings, but also the probes, because often how it is today in an agile world, what you do is you develop a very straightforward and easy implementation of an application. You deploy it, it's starting super fast, and everything is great. So you set your startups probes accordingly. Then 3 years later, a lot of code and a lot of business logic has been added. There are 5 migration scripts that have been executed when the container needs to be started, and all of a sudden it takes much longer to start, and you never revisited your probe. So what happens is that all of a sudden it takes five tries until your container is successfully running, because it's constantly killed by the kubelet. So it's actually good to regularly revisit those probes. I want to show you a little demo, or show you what that looks like on our cluster. We will have some time for QA later, but if anyone has any questions already, feel free to just shout them in. Yes? The liveness probe, that's a very good question. I think we actually still do use liveness probe a lot. The reason mostly is because the services are old and the startup probe wasn't existing yet, right? So usually it is to detect some bugs that you, for example, deadlock detection. You have some means to identify that your application is doing something or it's not doing something. You don't really know what the problem is, but you can identify that it's not doing anything anymore, right? Because, I don't know, because there's no more thread left in the thread pool or things like that. So you could use it for that. So the typical use case would be deadlock detection. Could be one use case. Right. Good. OK, so I don't know. I guess most of you are familiar with the kubectl command. It's actually the possibility to interact with Kubernetes on the command line. So we have a microservice architecture. Most of our microservices are either in Java or JavaScript. We have this one service that's called the campaign service. It's a plain Java service, and let's look at what its deployment looks like. I hope the internet bears with me. Oh. Let's see. No, it doesn't look good. All right, then you just have to believe me, and I will show you the fallback slides on it. I saw this coming, so. Yeah, so basically the command I executed is the kubectl described deployment of the campaign service, and it returns me the whole deployment descriptor of the service. And amongst others, so actually the service, it has two containers running, the main container and a proxy for the database. And this is the example we have here. We have the liveness, the readiness, and the startup probes. They are actually defined. This is the screenshot for the sidecar container, so for the database. And we see that they are triggered every 10 seconds, the liveness and the readiness probes, and the startup probe is triggered every 1 second, and we basically allow it to fail 20 times on startup. We have a delay of 0, so we start straight away. So we basically give the container 20 times 1 second to see that it is ready. And yeah, for liveness and readiness, we just continuously query the respective endpoints. And this is what it looks like when you look at the pods. So you see, that wasn't the intention. You see here, you have those 2 of 2. That basically means that 2 out of my 2 containers are ready to accept traffic, and everything is going as expected. They are running, so all looks good on them. So now, what I was doing, I was actually killing the pod, and I hope you can see it a bit down here. I'm not sure if it's very clear, but you can see here that the startup probe failed. The reason behind this is actually because that's one of those containers that's historically growing, and all of a sudden it takes much longer to start, and the probes haven't been tested accordingly. So at the beginning it's failing because the startup probe, it wasn't fast enough, and then you get this connection refused thing here, the error you get, and then it becomes healthy, but it was just 2 times, and then at the end the server was running again. And then you can see that here, that you basically have 1 out of 2 only running, and those are my two instances. And that was it from my side. So now time for questions, if any additional questions.